Okay, for this question you have to find dy by dx. Okay, so I'll be applying u dot v onto this part. Okay, onto this part. So sine y remains as it is, times ln x derivative is 1 over x. Okay, and plus sine y's derivative is cos y times dy by dx, and this ln x comes as it is. And then you have equal to 1 minus 2 cos y, and then you have dy by dx. So we have sine y over x plus ln x cos y. You must use brackets for this, okay? 1 minus 2 cos y dy by dx. Now I'll shift this 2 cos y dy by dx to the left hand side, and this will become ln x cos y plus 2 cos y, and then you have dy by dx, and this sine y over x will be shifted to the other side. So it's 1 minus sine y over x. Again, this you can write it as x minus sine y over x, while on the other side you can take I mean, this was to be like this. I have taken this dy by dx common as well when I shifted this 2 cos y dy by dx to the other side. Okay, and then this is going to become, finally you have dy by dx, that is x minus sine y over x, and all of this, if you see the cos y is common here as well, so this is going to be ln x plus 2, okay, dy by dx equal to x minus sine y over x. So I'll be writing this as x into cos y into ln x plus 2. That is it. That is the dy by dx in terms of x and y. Okay, in the second part it says, hence find the exact x coordinate, the point on the curve at which the tangent is parallel to the x-axis. At which the tangent is parallel to the x-axis. Okay. So for that purpose, when the tangent is parallel to the x-axis, so that would mean that what would be your gradient there when the tangent is parallel to the x-axis? So
So zero.
would that tangent be a vertical line or a horizontal line when it is parallel to x-axis?
Sir, horizontal.
Yeah, horizontal. So for the second part, you will put dy by dx equal to 0. So when you put that equal to 0, so you see this denominator will be cancelled out. So you only have x minus sine y, that is equal to 0. So your x is equal to sine y. So in the equation, you can put your sine y as x. Okay. So this becomes x ln x, that is equal to x minus 2x. Okay. So you have x equal to, sorry, x ln x equal to minus x. And then you bring this x to this side. This is x plus x ln x, that is equal to 0. So your x is common, that is going to be 1 plus ln x equal to 0. Okay, and then you have x equal to 0 or 1 plus ln x equal to 0. Okay, uh, our x cannot be 0 because this equation becomes undefined. So this is not possible. So you ignore this one. Okay, and then uh, we have here this uh, ln x equal to minus 1. So x equal to ln inverse of minus 1, that is e raised to power. So yeah, that is the right answer. That is 1 over e, exact value of your x. So this question is completed here. Okay, in this question you have been given y is equal to e raised to minus ax tan x, where a is a positive constant. So just remember that this a is a positive constant, okay? Has only one point in an interval 0 to pi by 2 at which the tangent is parallel to the x-axis. Find the value of a and state the exact value of the x-coordinate of this point. Okay, so for this tangent parallel to the x-axis, we know that this dy by dx has to be equal to 0. So we shall apply the product rule. So e raised to power minus ax derivative is minus a e raised to minus ax. And then you have tan x with this. And then plus e raised to power minus ax as it is. And then you have secant square x. Okay, tan x derivative is secant square x, and we put that equal to 0. From here, you see that your e raised to power minus ax is common. So you have minus a tan x, and you have plus secant square x, that is equal to 0. You put this e raised to minus ax equal to 0, and you get no value of x, okay? So the other one, this minus a tan x plus secant square x. Now, can I write, do you know that 1 plus tan square x is your secant square x, okay? So we can write it as here 1 plus tan square x. That is equal to 0, okay? Now it says it has only one point in the interval. So this would mean this relates to the for the quadratics. If you remember that if a quadratic equation has one solution, so do you remember that its discriminant is equal to 0 when you have equal and real roots? You remember that? Hmm?
Yes, sir.
So this tan square x minus a tan x plus 1, that is equal to 0. So its discriminant has to be equal to 0 because it has just one root. It should have two roots because it's a quadratic equation, but uh, since it's given, so we can use this condition here. So I'll put that b square minus 4ac. So that is a square minus 4 equal to 0. So your a square is 4 and your a is going to be 2. I'll not be writing plus minus 2 because again we given that this a is positive. Okay, look at this a is positive, it's given here. So A is 2. And then it says, state the exact value of the x coordinate of this point. So this now becomes tan square x minus 2 tan x plus 1 equal to 0. So you know that we can write it as a whole square. Tan x minus 1 whole square equal to 0, which means uh, that your tan x minus 1 is equal to 0, tan x equal to 1, and x is going to be pi by 4. That is the value of x within this interval from 0 to pi by 2. You see how much information, how much of the syllabus has been covered within one question. Is this apparently looks to be a question on differentiation, but you see that we have the concept of this exponential concept here, that why can't we have a solution here. Then you see there is the concept of quadratics coming in. Then you're applying the trigonometry over here while writing this secant square x as 1 plus tan square x, and then you solving it again, there is a trigonometric equation. So you see there are so many steps involved, techniques involved. That is why you have 7 marks for this one question here. Okay.